So good morning. Today I will start the topic IC engine. IC engine means internal combustion engine. Okay, internal combustion means combustion will be happening inside a cylinder. So we will have one cylinder, okay, and one piston will be there. This is called cylinder, and this is called piston. This shaded one, piston. When piston is moving up and down, the combustion will be happening here. Combustion or reaction, fuel and air you take inside this cylinder, combustion will be happening, and this will be creating high pressure gas. That high pressure gas will be pushing piston down, and because of this piston down movement, again another activity will be there, like piston will be moving up and down. So one reciprocating action will be happening continuously in piston. So that will be giving your rotary motion in a shaft. Okay, so this will rotate shaft. This will rotate a shaft, and shaft will be connected to your propeller. Okay, so the engine, whatever power it is producing directly, it may not go to your propeller, because engine, your propeller requirement will be different, your engine power production will be different. Sometime your ship is moving at very high speed, sometime it will be standing. Okay, so you need different amount of power. For example, bike you are driving, in traffic you are standing, your engine on, but your engine on, but you are not moving, right? Your car in traffic or in parking space you started, is not moving, but engine is on, right? So that time power requirement will lower, but after you start moving, your power requirement will be higher, especially initial when gear 1 you are giving, right? So initial power requirement will be higher, then you will be moving at cruise speed, so that time energy consumption will be lower. Okay, but still it will be higher than when you are standing. The power requirement that will be higher, power requirement will be higher when you are moving, right? So that means whatever power you are producing in engine, so same power may not be used in your propeller. Okay, then there will be different mechanism. So one mechanism is that we must have one shaft. Shaft will be transferring torque or power. So engine is rotating this one, this may be shaft, okay, at very high speed, and propeller will have speed 100 to 100 rpm. So that means we have to reduce the speed. Okay, engine is producing maybe 700 rpm or 1000 rpm, but your propeller needs 100 to 100 rpm. Okay, sometimes lower rpm also possible. That means you must have certain mechanism to reduce the speed. For example, your geared cycle is there, right? So sometimes you speed up, sometimes you speed up, just you change gear. So there will be certain mechanism to reduce speed of the shaft. Okay, then engaging, disengaging main shaft and propeller shaft. Main shaft means engine is producing power and shaft is continuously rotating, but propeller not rotating. Like bike, engine running, but you are not moving. That means some disconnection happening somewhere. Okay, engine running means shaft is rotating continuously, but your wheel is not rotating. In bike wheel, not your shipping wheel means that steering wheel. Actually, in ship term, wheel means steering wheel, right? But in bike wheel, I am saying like bike paya, right? Tire and tube, that wheel. So engine running, shaft rotating, but your wheel, propeller not rotating. That means some mechanism must be there, some clutch arrangement must be there. Okay, some clutch arrangement must be there. Then you are changing speed. I said speed changing when happening. So that means there will be certain mechanism called gearing mechanism. In your bicycle also you have gearing mechanism to change speed, right? So gear mechanism will be there. Okay, and when shaft is rotating, it will be holded by something, right? And it is rotating. So when it is, something is holding it, friction will be there, lots of friction will be happening. Okay, when lots of friction is there, energy loss will be there. Because of friction, energy loss will be here. So how to reduce that energy loss? So you will have bearing system. Okay, so you will have bearing, different types of bearings I will discuss later. Different types of like gear, clutch, other mechanism also I will discuss later. Just I am telling you the name, how things will work. So shaft is rotating, and it must be smooth rotation, friction will be lower, So there will be bearing mechanism. So bearing may be radial bearing, thrust bearing. Thrust bearing, what is thrust bearing? Propeller rotating. Okay, like say this is shaft, here propeller is connected. Okay, propeller rotating. When propeller rotating, actually it is pushing water. When pushing water, because of Newton's third law, water will be pushing in same with same force but opposite direction, right? That means shaft will get another force, axial force. One torque is transmitting, but it is getting axial force also. Okay, so but axial force you cannot transmit to your engine. Engine very much sensitive. It is producing power. It do not give extra load, right? So someone is doing some work and you are giving extra load. So that person can fail. Okay, he may not take, the engine may not take the extra load. Okay, so you have to make certain arrangements so that load will not get transferred to the engine. Propeller is giving extra load, axial load, so that must not be transferred to engine. So then what to do? We must have certain bearing arrangement called thrust bearing. So thrust bearing will take axial load, but it will allow rotational movement. Okay, so we will have bearing radial and thrust. Okay, now sealing arrangement. Sealing arrangement means you have stern tube. You may have heard stern tube. Okay, so propeller is rotating here, bearing is here, and bearing must be lubricated. Lubricated means like in your bike or car or bicycle, you add sometimes grease or sometimes thick fluid. If you go to cycle shop, they will be putting some thick fluid, mobile or lubricating oil, they say. Sometimes they will be putting grease, semi-solid, some metal, right, black color or some yellowish color they will be putting. So this is called lubricating oil, or to reduce friction. Okay, now when propeller rotating, propeller will be passing, propeller shaft will be passing through one bearing. Okay, so bearing must be lubricated to reduce friction. Now when propeller rotating, water splash will go into this lubrication section. Okay, when it is going to lubrication section, lubrication will be washed away because of seawater. Then you have to seal properly both side. Like I say, this is my bearing is holding, and seal this end, this end. So sealing is must be proper. So sealing will not allow water to enter, or inside grease or lubricant, whatever is there, it should not go out. Okay, so the sealing is called stern tube sealing. So this is my propeller, shaft is going there, shaft is going through one seal section, seal and bearing, it's called stern tube. Okay, and this lubricating oil or grease, it should not go out, so you must seal properly. Okay, these days there are new seal arrangement came up, water based seal and other types of seals. If you are using hydrocarbon based sealing, lubricating oil, so what happens in hydrocarbon, if it is going to water, your MARPOL is there, Marine Regulatory Authority, they will be filing a case against you. Okay, so then you must make proper arrangements so that your hydrocarbon based lubricating oil or grease should not go into water, seawater, because of pollution issue. Okay, so sealing must be there. I wrote, I think, sealing arrangement, sealing and bearing. Okay, so your engine producing power, engine power is transferred to one shaft. Shaft will have connection of gear mechanism, because you want to reduce the speed. Shaft, main engine shaft higher speed, propeller speed lower, you must have gear mechanism to reduce the speed. You must have some clutching mechanism. Okay, then that shaft will be held by some bearing. Bearing must be lubricated to reduce friction. Okay, so all these things I'll be discussing actually in this course. Okay, so first will some lectures are there in first week of my course. I have told about different thermodynamic laws, like first law, second law, third law, zeroth law. So there are 4 thermodynamic laws: first, second, third and zeroth law. Okay, yeah, so you can recap from your books. Even in first week lecture also I have given those theories. And first law says energy can be converted into heat, heat can be converted into water, work. But in second law says heat and energy convertible, but 100% not possible. Some losses must be there every time. Okay, so that theory says perpetual motion machine. So any machine you design, it will be running continuously without taking external energy, not possible. Okay, so our whatever engine related discussion will do, will consider some losses will be there every time. Okay, if we say some ideal situation, so in that case we ignore the losses, but normally when you are converting heat to energy, energy to heat, okay, so there will be certain amount of losses. So work can be converted to 100% heat, but heat cannot be converted into work. So this is given in second law of thermodynamics. Okay, and third law and zeroth law, this is a different story, but basically all these things will be based on second law. Okay, first law and second law, you can say. So first, whenever you discuss about any engine, we discuss with Carnot cycle. So Carnot cycle will have some theorem. Carnot cycle means this engine, one certain engine, that engine will have maximum efficiency. So any engine you design, that engine efficiency will be lower than this Carnot cycle efficiency. Okay, this Carnot cycle defines the maximum efficiency possible between two temperature, hot temperature, low temperature, you have high temperature, low temperature. The Carnot cycle, the formula will be giving the highest efficiency. Okay, so we have many other cycle, diesel cycle, Otto cycle, Ericsson cycle, Brayton cycle. So all those cycles will have lower efficiency than Carnot efficiency. Fine. So Carnot theorem often referred to as Carnot principle or Carnot's theorem, 1824, 200 years ago. Carnot's theorem states that no heat engine operated between two heat reservoirs can be more efficient than a Carnot engine operating between the same reservoir. Okay, so high temperature TH, you see top picture TH, high temperature TC, this is hot, I can say, this is cold, I can say. Okay, and if this is engine, so Carnot engine will give the maximum efficiency. Okay, in other words, the efficiency of a reversible heat engine, reversible and irreversible. Reversible means like we assume entropy constant and system can move from A point to B, B to A possible. When we talk about irreversibility, from second law of thermodynamics, irreversible means some energy will be lost every time. Okay, so because of friction or because of heat transfer, because whenever any process will be happening, so there will be certain heat transfer to the environment, so that you cannot recover. Okay, so because you cannot recover, so that will be considered as a loss of energy. Okay, so whenever we are talking about reversible heat engines, means we are assuming the 100% heat transfer to work transfer to heat. Okay, is the maximum possible efficiency for any heat engine operating between two heat reservoir at different temperatures. Two heat reservoir means hot TH and T cold. These two reservoir we are assuming. For example, environmental, this room temperature can be considered as a heat reservoir. Okay. Okay. So this week 6 lecture basically I have taken from textbook Basic and Applied Thermodynamics, PC NAG or PK NAG? PC NAG, right? I have written PC, but is PC or PK? PK NAG, right? Okay, so I have taken this lecture from PK NAG book. I think it should be PK NAG, or any standard textbook on IC engine. You take basic book on IC engine. There will be lots of books available for IC engine discussion, advanced book also. So we will not discuss advanced part. We will go through only basic part, basic simple calculations, because it is marine engineering course and we have only few lectures allotted for this IC engine. Okay, so gas powered cycle. So gas powered cycle means like we have fuel plus oxygen and we burn it and we get burned gas. Okay, so this burned gas will be driving your system. So this is called gas powered cycle. So another cycle is the steam powered cycle. Okay, in steam powered, actually the coal, especially steam engine, if you see coal or any fuel will be burned, so that fuel will be giving heat to water, water will be heated up, so water will be producing steam, so that steam will be running your turbine system. Okay, so it's called steam powered system. But in gas powered cycle, IC engine, you will have gas turbine engine. Okay, IC engine means internal combustion engine. Okay, and gas turbine engine, so this is a little bit different. I will discuss later regarding gas turbine engine. That is also gas powered engine. So fuel will be burned, so hot gas will be passing through turbine and turbine will be rotating, and during rotation it will extract energy from hot gas and it will produce torque. Torque means power actually, because power equals T into omega. Torque into our rotational speed. Okay, whenever I am talking about torque and it is having rotation, that means actually I am talking about power. Okay. So engine operates under engine operates under cyclic or non-cyclic condition. Cyclic operation means, like if I say gas turbine engine, in that case we assume this is non-cyclic. Gas turbine engine, this is non-cyclic operation. We will discuss later. Okay, IC engine, we assume this is cyclic process. What is that cyclic process? If I draw PV diagram, so process will be happening like this in internal combustion engine. Compression will be happening 1, 2, 3, 4. Okay. So in IC engine, okay, but if I see gas turbine engine, so that thing will not happen. Compression will be happening, combustion will be happening, then so cycle is not complete. 1, 2, 3, 4. Okay, but cycle is not complete. But in IC engine we assume cycle is complete. Okay, these are assumption. Actually cycle, whatever gas we produce in IC engines, the same gas will not be circulating. So actual case it is not cyclic process, but for our simplification we make it, if we assume it is a cyclic process. Okay, so but in gas turbine engine we do not assume that one cyclic process. Okay, so this is gas turbine engine. Okay, we will discuss later, so you will understand what is this PV diagram. Okay, so we talked about Carnot cycle. So in Carnot cycle, when we represent Carnot cycle, we draw TS diagram. So 1, 2, 3, 4. So this discussion is already there in week 1 lecture, so you should go through this. Okay, so in Carnot cycle we will have 2 reversible isothermal process, 2 reversible adiabatic process. Okay, adiabatic means no heat transfer happening, isothermal means complete heat transfer happening. Okay, they say you are compressing certain gas, okay, with very slow speed. So in that case heat will be transferred to atmosphere, right, and it will be maintaining same temperature continuously. So this is called isothermal process. But if process is very fast, suddenly you are compressing something, so in that case heat transfer so quickly not possible. So that is called adiabatic process. So adiabatic process is also called isentropic process. Okay, entropy will be constant. Okay, but in isothermal process heat is getting transferred, so entropy is changing and your temperature is constant. Okay, so reversible isothermal process, which one? 1 to 2 is isothermal process, 3, 4 is isothermal process, while 1, 4 is adiabatic process, 2, 3 is adiabatic process. Okay, and so you should remember the names. Isothermal means same temperature, adiabatic process, isentropic process, S is constant, entropy constant. Sometimes we use isochoric process where your volume is constant. Okay, isobaric process, pressure is constant. So those terms you should remember. Fine. And same thing if I draw in PV diagram, pressure and volume diagram, PV, so it will be like this. One, 2, 3, 4. Okay, here I can assume heat input is happening, heat rejection is happening here, compression work is happening, we are getting power output. So here same thing I can replicate. TS diagram here. Actually, it is coming like this. So, compression work is happening, expansion work, or we are getting work output, heat input, heat output. Okay, so Q is heat. Okay, Q1 heat input, Q2 heat output, heat exhaust, and WC compression, WE expansion process. So, what is this compression expansion process? If I take certain amount of volume, okay, and I have one piston here, certain gas is here, okay. So, initially start pushing the piston up. When you pushing up, compression happening, okay. So, compression happening, if it is very slow process, then heat will be transferred, okay. Again, if you remember the Boyle's law, actually it is isothermal process. Why that time he did not have any system to make system faster, so he made everything slower. So slowly compression was happening. So PV equals constant, he produced the formula, okay. When isothermal is there, PV equals constant. When adiabatic, we are saying PV power gamma equals constant, right? So isothermal, where can I write? Isothermal, PV constant, adiabatic, PV power gamma equals constant. So later stage, when people got machinery to compress things very faster, so that time they produce this formula PV power gamma equals constant, okay. And yeah, so Boyle's law should be very slow process and low pressure application, not too high pressure, okay. That time he did not have a very system with very high compression system, okay. So very lower compression and slow speed, that is used for Boyle's law, okay. There is a limitation of Boyle's law. But if you are thinking about adiabatic process, PV per gamma would be there and system should be fast, so heat transfer should not occur, okay. But if in certain cases, later we will discuss, if heat transfer is occurring, so that time we say polytropic process. So it is not isothermal, not adiabatic, in between something happening, then we say polytropic. So normally for IC engine discussion, internal combustion engine discussion, we do not consider this one as polytropic process. We consider this as a adiabatic process, okay. So isothermal not possible in IC engine because piston movement will be very high at very high speed, so it is not isothermal. So it should be adiabatic or polytropic, but the system moves at piston moves at very high speed, so we assume this is a adiabatic process and it is air. So our gamma value will be 1.4, okay. Specific heat ratio will be 1.4, okay. So whenever you are talking about gas power cycle, so we have two system, one is gas turbine system, one is IC engine system, okay. Whenever talking about IC engine, so we have to go through certain assumptions. So first assumption, we will assume this is air standard cycle, means air as a working fluid, and air is an ideal gas. Practically if you consider, then it is not ideal gas, but here we are assuming this is an ideal gas, gamma value 1.4, done, okay. PV equals nRT formula should be applicable. Constant specific heats, Cp specific heat when pressure is constant, when volume is constant, okay. These are also constant. Neglecting mechanical friction, when piston moving up and down, so friction will be there. So we are assuming there is no losses, okay. We are making it idealized. Heat transfer losses also we are ignoring. I said like this is adiabatic process we are assuming. Instantaneous and complete mixing of air and fuel during combustion. Entire process as a closed cycle. Mass flow rate is constant. So when system is occurring, so mass flow rate is constant. We will discuss what is the mass flow rate and all these things later, okay. Just you presently you remember these assumptions. So whenever you are talking about IC engine, so there are several terms actually you should remember. IC engine term will be there, internal combustion engine. Another term is there, CI, it is called compression ignition engine. Compression ignition. Okay, SI means spark ignition. Okay, normally your bikes, cars will be having spark ignition engine, okay. There will be 2-stroke, 4-stroke engine also. So we will discuss later what is 2-stroke, what is 4-stroke. First get first try to understand what is IC engine. So IC engine will have one cylinder. Okay, you see this is a cylinder. Okay, it will have, this is called cylinder, and this will have valves. Okay, 2 valves are there, another valve is here, and this is spark plug. And this is called piston, this one. Okay, this is called piston. This is called connecting rod. There will be one crank actually. You cannot see the crank part, so crank will be here. So I will draw another picture. Same thing I am drawing in 2D format. You also can draw if you like. Okay, so connecting rod, crank. Okay, so this is piston. I will have valve here. This is cylinder. So whatever I have copied from iStock pictures website, same thing I am drawing here actually. So this is crank, this is connecting rod. Connecting rod, this is crank, this is called crankcase. Okay, whenever you are discussing about IC engine, you should know the terms. Okay, so many times we will be saying okay crankcase, but if you do not know the term what is crankcase, then it will be difficult for understanding. Okay, so this is crankcase, and this is piston, this is a cylinder, cylinder. Okay, and valves will be there. Then there will be one spark plug. Your car or bike will have spark plug. Okay, so one spark plug will have, because if it is SI engine, spark ignition engine, then there must be one spark plug. So that's why spark term is there, spark ignition, SI. Okay, another type of engine is there, CI engine, compression ignition engine. In that case, spark plug will not be there. Okay, later we will discuss about CI engine. So first you assume this is spark ignition engine. Okay, so we have crankcase. A crankcase will have lubricating oil actually, lots of lubricating oil. Because if you have bike or car at your home, you can see this after certain time you have to remove this oil, engine oil they say. Okay, and again you have to fill that engine oil. So this is called lubricating oil. In scientific or technical term is lubricating oil. OIL. Okay, so but normal people will understand this is engine oil. Okay, if you go to any shop they will say engine oil, right? So normally it will be like yellowish color oil initially when they will be putting. After 2-3 months or 6 months, you will say it will be almost blackish color. So if you do not change the engine oil for maybe 1 year, it will be more thicker. Okay, when it is thicker, engine will not start, or engine will create a problem. So time to time you have to change the engine oil. So later I will discuss about lubricating oil, its property, why you should change. Okay, basically I am not discussing, I am just explaining the system first. Okay, so if you see the piston in this picture, top picture, so piston is having certain grooves like this. You see grooves. Okay, so grooves are called piston. There will be piston rings. Okay, so there will be piston rings. Okay, and piston cylinder will have one top dead center, TDC, called top dead center. So center spelling British or American, just you can decide. C and TER I wrote, and you can write C and TRE also, because if you are following British spelling. Okay, and there will be one top dead center, bottom dead center, BDC, bottom okay. So what happens if you rotate the crank? You see this connecting rod will be pushing piston up and down. Okay, so if you rotate crank, you say A, B, C. Okay, A means shaft. Here crank is here, and crank is rotate around this one. Okay, when crank is rotating, you see this connecting rod will be moving up and down. BC, that rod is called connecting rod. Connecting rod will be moving up and down. When it is moving up and down, piston inside the cylinder will be sliding up and down. Okay, you give crank one rotation, piston will be moving one time up, one time down. Okay, so up and down the maximum distance following is called stroke. Okay, so how much distance it will move from top dead center to bottom dead center? Okay, BDC to TDC stroke. Okay, so piston will have one crank rotation, one complete crank rotation, 360-degree rotation. My piston will be moving upstroke, downstroke. Okay, crank 360-degree, piston moving up and down. Okay, so piston moves upstroke, or piston completes, I can write upstroke, and when crank rotates 360-degree. Fine. So when crank is rotating 360-degree, my piston will be moving up and down. So you increase your crank rotational speed, your piston movement will be faster. Okay, in our normal IC engine application, car, bus, truck, train also there, these diesel trains are there, right? Because previously it was coal based engine. Now government has replaced almost all coal based engine. Only heritage trains are there. Most probably this Uti and Darjeeling, those trains are there for heritage purpose or tourism purpose they have kept. Otherwise normally all trains are replaced by your diesel engine or electrical engine. Okay. Okay, so your IC engine will have one crankcase, one crank, one connecting rod, piston ring, cylinder, valves, spark plug. In some cases, if it is CI engine will have a nozzle. Okay, later I will discuss what is the difference between SI and CI. CI engine will have nozzle and it will be injecting fuel in atomized form. Okay, but SI engine, it will be mixing air and fuel, then it will be injecting into the cylinder. Now what is happening when piston is moving up? Okay, let's close all the valves. Maybe I'll. Okay, you see the second picture. I will put number 1, 2, 3, 4. Okay, you see the top pictures. So first you take air fuel mixture inside cylinder. Okay, you see the picture 1. Okay, inside you take air fuel mixture, close all the valves. Now start pushing piston up. When piston is moving up, compression will be happening. When compression happening, air temperature will be increasing. When air temperature increasing, you give small spark. You see second picture, spark is there, small spark is happening. Okay, small spark means small fire source you give. Okay, so that will give small reaction. So that will be produced, that will be exothermic reaction. When fuel is burning, it will be exothermic reaction. Okay, fuel plus air plus fire source, it will create exothermic reaction. So the exothermic reaction will be producing more heat. Heat will be transferred to another molecule, then whole mass, whatever inside cylinder is there, air and fuel mixture, it will be burnt. Okay, there is a combustion or reaction is happening. So when combustion happening, the small air and fuel mixture, it will create very large volume because temperature increased now. Okay, because of Charles law, temperature increased. Temperature increased means pressure increased, volume increased. Okay, so you see the fire, third picture, you see lots of fire happening inside cylinder. Okay. So then high pressure piston will be pushed down. Piston pushed down means crank will be rotating. Okay, but crank rotated, when crank at the bottom portion, then open some certain valves. Okay, then you reduce the pressure. When again crank is moving up, again you compress, give fire, you pressurize. So continuously this sequence will be happening. Okay, take fuel air mixture, compress it, give fire, then it will burn, it will create very high pressure, piston will be pushed down, crank will be rotating at the same time, because my connecting rod is linked to my connecting rod is linked to crank. So when connecting rod is getting pressure from piston, connecting rod is rotating half, again because of certain mechanism you push it up, again compress, burn, push it down. So one time you are giving power, another time you are not giving power actually. So you are getting one power stroke every time. 360 rotation, you are getting one power stroke. Power stroke means one time it is forcing down. Forcing down means crank will be rotating half, another half will be rotated by its own mass. So here one mass is here. Okay, this is balancing mass. Okay, when piston is moving down, it is getting power. When piston wants to move up, so that time it needs some power. So this mass, extra mass is there. So that mass will give extra momentum to compress certain amount, give spark, create pressure. So that way things will be rotating. Okay, so lots of YouTube videos are there. Please try to watch. Okay, how things are working in sequence. Okay, now I'll draw the PV diagram, pressure and volume, and TS, temperature, entropy. So I'll be drawing one piston cylinder arrangement here again. Oh, sorry, I'm not drawing all the connecting rod and casing thing, just I'm turning vertical piston to horizontal so that I can draw in PV diagram properly. Okay, and piston will not move up to the end, it will keep certain gap because of mechanical reason. Okay, so this is called top dead center. Okay, piston will be moving maximum this one, so this is BDC. So piston is moving from top dead center to bottom dead center. Top dead center is not the end of the cylinder, because certain gap we have to give, otherwise this piston will be coming and it will be touching continuously this top section, it will break. Okay, so we don't want to touch every time piston and this cylinder. Okay, so that's why we should give certain amount of small amount of gap. Okay, so that maximum piston traveling, that is called TDC, top dead center, minimum bottom dead center. Okay, now PV diagram. Let's assume okay, assume initially my piston is here. Okay, piston at the farthest end, at the bottom dead center. Okay, now your cylinder is filled with lots of air. Now you start compressing, you close all the valves and start compressing. What will happen? Compression will be happening. Okay, what type of compression? I said adiabatic compression. Okay, adiabatic compression. Okay, adiabatic compression means we are assuming there is no heat transfer, just you compressed. Now after that, after compression, what will happen? I said like a spark, you give some spark and burning will be happening. So give a spark and burning is happening. Okay, so 1, 2, 3, 2 to 3 burning happened. Burning happened means you got lots of heat. So what will after that, what will happen? That high pressure gas piston will be pushed backward, TDC to BDC. Piston is moving backward, TDC to BDC. So again the formula. Okay, adiabatic compression, adiabatic expansion, piston moved down, so adiabatic expansion happening. Okay, then 4. So you have to put arrow also whenever you are, if I ask you to draw the PV diagram, so you should put properly arrow direction. If you are putting wrong direction, I may not give marks. Okay. And once it reaches to 4 means this bottom dead center, all gas should go out. So we are assuming instantaneously gas went out. Okay. And 2 to 3, if you see, piston is the top dead center, and instantaneously you are giving all the energy. Okay, practically is not possible when piston is moving very high speed, going up down. So when it is reaching a top dead center, it is not having enough time to get heat actually. But to approximate, we are assuming this is ideal case, and instantaneously it is getting all heat. So process 2 to 3 instantaneously happening, and 4 to 1 also we are assuming instantaneously all gas is out. Okay, and all intake also happened, and 1 to 2 again compression happening, 2 to 3 heat addition. So 2 to 3 process is heat addition. Okay, 4 to 1 exhaust. So when we are getting power, 3 to 4, this is power stroke. Okay, so when piston is moving TDC to BDC at very high pressure, because of high pressure gas, we are getting power. So this is called power stroke. Okay, and if I draw the same thing in TS diagram, TS diagram will have like this, 1 to 2 adiabatic process. So I am assuming this is isentropic, no heat transfer happening. Okay, 2 to 3 heat addition my temperature increasing. 3 to 4 expansion happening, I am getting lots of power. 4 to 1 exhaust happening. Okay, so this if I ask you draw PV TS diagram with your one piston cylinder arrangement, so you should give proper nomenclature, name 1 2 3, mismatching of number or arrow direction wrong, I will not give marks. Okay,